So you got stabbed. That's not good. In response to that, nociceptors and mechanoreceptors are going to fire in your body, opening up ion channels and allowing ions to flow in and out of your neurons based on their gradient and voltage.
Yeah, so a closer look at those in the cell. Inside the cell, you have potassium, and then outside you have sodium and chlorine. So sodium wants to get in the cell both chemically, so gradient-wise, and based off of its voltage. So it has a strong desire to go in. And then potassium has a small drive out of the cell based off of its gradient, but it kind of wants to stay in voltage-wise. And then chlorine wants to, it kind of just stays where it is. It's canceled out gradient-wise and voltage-wise. And then also inside the cell, you have some anions, which are too big to leave the cell. They kind of just are stuck in there. And then we also have this concept of resting membrane potential, which is at -70 millivolts. And that's the difference in charge between the outside and the inside of the cell based off of these ions. And then we also have the concept of summation. So that's where multiple signals kind of add up to create an action potential.
Right. So over here, this is inside the cell. Channels opened up. Sodium really wants to get in. That is going to slightly raise the voltage inside the cell from -70 until it hits about -55. And that is going to open up voltage gated sodium channels. And that allows a lot more sodium to pour in, all the way spiking up to about +30, where the voltage gated sodium channels are going to close and voltage gated potassium channels are going to open. Now potassium already wants to get out a little bit, and now the voltage is way raised, so it wants to get out more. So potassium is going to dump out of the cell, bringing it back down. And it takes a little bit longer for those to close. So it's actually going to go into a period where it is lower than it was resting before, and then slowly recover through some leaky channels, and the sodium potassium pumps are going to kind of reset it to its resting state so the neuron is ready to fire again. Another piece of the neuron itself is myelination. This occurs in the middle of it, and myelination is kind of a fatty insulation around the neuron that prevents these ions from flowing in and out, and instead they just kind of get pushed along the neuron, allowing a much faster current to travel through and reach up at the end to send the signal into the next neuron.
And then, so speaking of sending the signal to the next neuron, just to get our bearings, this is the presynaptic neuron, and then this is the post. And then right here is our synaptic cleft. All right, so basically the action potential arrives at this terminal axon right here, or axon terminal, and then there's calcium channels kind of on the end here, and these are opened, which allows calcium to enter into the cell. And basically once calcium enters in, these vesicles that are filled with neurotransmitters can release the neurotransmitters into the cell, and then those neurotransmitters are then released across the synaptic cleft, and then the neurotransmitters will bind to specific receptors on the postsynaptic neuron, and then that's kind of what allows the electrical message to turn into a chemical message to jump over the synaptic cleft and enter into the postsynaptic neuron.
Yeah, so the chemical message going across the synaptic cleft is represented in two ways. There's excitatory and inhibitory postsynaptic potentials that are created. Excitatory postsynaptic potentials are depolarizing to the next neuron, the postsynaptic neuron. And those two are acetylcholine and glutamate that will get sent across to depolarize the next neuron, and that will cause the message to be continued to descend along through the body. Inhibitory postsynaptic potentials, serotonin, histamine, and dropping my marker. And those will hyperpolarize the neuron and drop it lower, so it's even harder for it to fire, and those will combine, and kind of the winning potential will cause what happens next in the cell.
Yeah. And then, so we have these neurotransmitters that are on the neuron, and basically we don't want those to be there forever, because then it would just continuously send that action potential. So there are some ways that the neurotransmitters are eliminated from those receptors. One of the ways are reuptake, so the neurotransmitters are taken back in, and then also enzymatic degradation, and then also diffusion. And also leaky channels and sodium and potassium pumps restore the cells back to their resting memory potential, so that it can receive a new message later on. Yeah.
Cool.
So everything works.